friends, welcome to Tech Space. Today we are going to discuss on the topic Chandrayaan 3. Topics to be covered: Chandrayaan 1, Chandrayaan 2, cause of failure of Chandrayaan 2, Lunar 25, cause of failure of Lunar 25, motive of Chandrayaan 3, structure of Chandrayaan 3, aim of Chandrayaan 3, total budget of Chandrayaan 3. Chandrayaan 1. Chandrayaan 1, India's first mission to moon, was launched successfully on October 22, 2008. The spacecraft was orbiting around the moon at a height of 100 km from the lunar surface for chemical mineralogical and photogeologic mapping of the Moon. The spacecraft carried 11 scientific instruments built in India, USA, UK, Germany, Sweden, and Bulgaria. After the successful completion of all the major mission objectives, the orbit has been raised to 200 km during May 2009. The satellite made more than 3,400 orbits around the Moon, and the mission was concluded when the communication on with the spacecraft was launched on August 29, 2009. Chandrayaan 2. Chandrayaan 2 mission is a highly complex mission which represents a significant technological leap compared to the previous mission of ISRO. It comprised an orbiter, lander, and rover to explore the unexplored south pole of the Moon. The mission is designed to expand the lunar scientific knowledge through detailed study of topography, seismography, mineral identification and distribution, surface chemical composition, thermophysical characteristics of topsoil, and composition of the tenuous lunar atmosphere, leading to a new understanding of the origin and evolution of the Moon. After the injection of Chandrayaan-2, a series of maneuvers were carried out to raise its orbit, and on August 14, 2019, following translunar insertion (TLI) maneuver, the spacecraft escaped from orbiting the Earth and followed a path that took it to the vicinity of the Moon. On August 20, 2019, Chandrayaan-2 was successfully inserted into lunar orbit. While orbiting the Moon in a 100 km lunar polar orbit on September 2, 2009, Vikram lander was separated from the orbiter in preparation for landing. Subsequently, two-day orbit maneuvers were performed on Vikram lander so as to change its orbit and begin circling on the Moon in a 100 km into 35 km orbit. Vikram lander descent was as planned and normal performance was observed up to an altitude of 2.1 km. Subsequently, communication from lander to the ground station was lost. Cause of failure of Chandrayaan-2. The Chandrayaan-2 mission was launched by the Indian Space Research Organization (ISRO) on July 22, 2019 and consisted of an orbiter, a lander, and a rover. The orbiter successfully entered the lunar orbit and is still functioning, but the lander and the rover lost contact with the ground station during the final descent and crashed on the lunar surface on September 7, 2019. The reasons for the failure are still being investigated by ISRO, but some possible factors are software glitches, communication errors, and thruster malfunctions. The failure of Chandrayaan 2 was a setback for Indian space ambitions, but also a learning opportunity for future missions. Lunar 25. Lunar 25 was a Russian lunar lander mission that launched on 10 August 2023 and crashed on the moon surface on 19 August 2023. It was the first lunar lander that Russia sent to the moon since 1976, and it aimed to explore the lunar south pole and the region that may contain frozen water and other resources. The mission failed after a problem with the orbital maneuver that was supposed to prepare the lander for a soft landing. Cause of failure of Luna 25. According to the head of Russia's space agency Roscosmos Yuri Borisov, the cause of failure of Luna 25 was an engine issue that prevented the lander from performing a soft landing on the lunar south pole. He said that the engine that was supposed to correct the course and lead the spacecraft to a pre-landing orbit did not shut down normally, but according to a temporary cutoff, instead of working for 84 seconds, the engine worked for 127 seconds, which caused the spacecraft to crash. Borisov also blamed the decades of inactivity in Russia's lunar program as the main reason for the failure. He said that the experience and technologies that were developed in the 1960s and the 1970s were practically lost during the interruption of the program. He vowed to continue the lunar program and accelerate the next mission, Lunar 26 and Lunar 27, which are planned for 2024 and 2025 respectively. Lunar 25 was Russia's first lunar mission since 1976 and it aimed to explore lunar South Pole, a region that may contain frozen water and other resources. It was launched on August 10, 2023 from the Vostochny Cosmodrome in Russia's far eastern Amur region and entered the lunar orbit on August 16. It crashed on August 19 at 11:57 UTC C352. Motive of Chandrayaan 3. The motive of Chandrayaan 3 is to explore the lunar South Pole, a region that may contain frozen water and other resources that could be useful for future human mission to the moon. Chandrayaan 3 is also India's second attempt to achieve a soft landing on the moon after the failure of Chandrayaan 2's lander Vikram in 2013. 2019 Chandrayaan 3 aims to showcase India's technological power and scientific curiosity in the field of lunar exploration. Chandrayaan 3 consists of a lander and a rover which will carry out in situ chemical analysis of the lunar surface during their mobility. The lander will also have instruments to measure the seismic activity, temperature, and plasma density on the moon. The rover will have cameras, spectrometers, and a laser-induced breakdown spectroscopy (LIBS) instrument to study the composition and morphology of the lunar soil. Structure of Chandrayaan 3. The structure of Chandrayaan 3 is as follows. Propulsion module. It is a box-like structure with a large solar panel mounted on one side and a cylindrical mounting structure for the lander on top. It has a mass of 2148 kg and generates 758 watt of power. It communicates with the Indian Deep Space Network IDSN and also carries a scientific payload called SHAPE which studies the polarization of Earth's atmosphere. Lander module. It is named Vikram after the father of Indian space program, Dr. Vikram Sarabhai. It has a mass of 1,726 kg, including the rover of 26 kg. It generates 738 watt of power with solar panels and batteries. It communicates with IDSN, Chandrayaan 2 orbiter, and the rover. It carries four scientific payloads: Rambha, which measures the plasma density and electric fields near the lunar surface; Chaste, which means the thermal conductivity and temperature gradient of the lunar regolith; ILSS, which detects seismic activity and moonquakes; and LRA, which is a passive reflector for laser ranging from Earth. Rover module. It is named Pragyan, which means wisdom in Sanskrit. It has a mass of 26 kg and generates 50 watt of power with solar panels and batteries. Its communication only with the lander. It carries two scientific payload. APXS, which analyzes the elemental composition of lunar rocks and soil, and LIBS, which uses a laser to vaporize a small amount of material and analyze its spectrum. Team of Chandrayaan 3. The team of Chandrayaan 3 consists of many talented and dedicated scientists from ISRO who have worked hard to make this mission a success. Some of the key members of the team are S. Somnath, ISRO chairman. He is an aerospace engineer who has led ISRO since 2022. He has been involved in the development of rocket technologies for ISRO, including the GSLV Mark III, which launched Chandrayaan 3. M. Sankaran, Director, UR Raw Satellite Center, URSC. He is responsible for the design and construction of India's satellite, including the Chandrayan 3 orbital lander and rover. He joined URSC as director in June 2021. P. Veeramuthuvel, project director of Chandrayaan 3. He is the main scientist who led the Chandrayaan 3 mission. He has been with ISRO since 1990 and has worked on various satellite projects. He became the project director of Chandrayaan 3 in 2019. Srikanth, mission director of Chandrayaan 3. He is the one who oversaw the operation and execution of the Chandrayaan 3 mission. He has been with ISRO for over 2 decades and has worked on several launch vehicle and satellite missions. Kalpana, Associate Project Director of Chandrayaan 3, she is the one who assisted the project director in managing the Chandrayaan 3 mission. She has been with ISRO for over 15 years and has worked on various satellite projects. She is one of the few women scientists in ISRO's leadership team. Jayan Datta, scientist from Assam, he is one of the young scientists who was part of the Chandrayaan 3 team. He hails from Assam and has a PhD in aerospace engineering from IIT Bombay. He has contributed to the development of the lander and rover system for Chandrayaan 3. These are some of the brilliant minds behind India's historic lunar exploration mission. They have made the nation proud with their achievement and dedication. So we are proud of them. A salute to them. Total budget of Chandrayaan 3. Former ISRO chief K. Sivan shared with reporters that Chandrayaan 3's budget surpasses that of its predecessor by approximately 300 crores. Back in 2020, ISRO chairman K. Sivan stated that the total cost of Chandrayaan 3 was 615 crores. This includes 250 crores for propulsion and an additional 365 crores for launch expenses.